Hi guys, in this video we're going to be talking about differentiation rules, specifically talking about the quotient rule. Now, a quotient is just another name for a fraction. So what the quotient rule does is it gives us a way of differentiating fractions. In our fraction, we'll refer to the top part as u and the bottom part as v. The quotient rule states that if I want to differentiate this fraction, the result will be another fraction, and the top will work out as v times the derivative of u minus u times the derivative of v. And on the bottom of the fraction, we'll have a v squared. Now, this formula is given in the formula booklet on the WJEC syllabus, but it's not written in the exact same way. What might help you remember this is the v's form a v shape. This is something that's quite nice, which might help you remember which way around it goes. Unlike the product rule, this is not symmetrical, so we can't swap these things around. Let's have a look at a few examples of this in action. Okay, here's our first example. Our fraction is e to the x divided by 1 plus x. So we've got our function u and our function v established to begin with. Now, like what I did with the product rule, I am going to write these down and differentiate them both separately first of all. U is e to the x, v is 1 plus x. Now, differentiating e to the x keeps it exactly the same, so it's going to remain as e to the x. Differentiating 1 plus x, 1's a constant, so that's going to go, and x differentiates to 1. So with a bit of foresight, it's going to be quite nice. We're going to be multiplying some terms by 1. The quotient rule then says that differentiating a fraction is going to give us v du minus u dv, all divided by v squared. So in this particular instance, we're going to have v, which is 1 plus x, multiplied by du, which is e to the x, minus u, which is e to the x, times by dv, which is 1. The bottom of the fraction is v squared, which is 1 plus x squared. Now, there might be some simplifying I can do here. I'm going to expand these brackets just to see how it all interacts. So let's see. So d by dx is e to the x times 1 is e to the x. The other term is x, e to the x. E to the x times 1 is just e to the x. And the denominator is going to stay as it is. Now, something convenient here is we've got e to the x here, we've got minus e to the x there, so they are going to cancel out. And the final result is going to work out as x e to the x divided by 1 plus x squared. And there's my derivative for example 1. Here is example 2. We're going to differentiate tan x, and we're going to do so by using an identity that we learnt in the first year of the course. We do have something to aim for here. We are given that tan x should differentiate to 1 over cos squared. Sometimes that's called sec squared. When you study trigonometry within the course, that will become a little bit more familiar. Now, let's set up our problem. We have u as our top function, which is sine x in this case, and we've got v as our bottom function, which is cos x. If I differentiate sine, I should get cos, and if I differentiate cos, I should get minus sine. Now again, putting this into the quotient rule, in this instance, I'm going to get v, which is cos x, multiplied by du, which is cos x again. Then I've got u, which is sine x, and I'm multiplying by dv, which is minus sine x. The v term is cos, so the denominator is going to be cos squared. Now, the eventual answer matches in terms of the denominator, but not quite on the top yet. We've got a 1 here. It's not immediately obvious where that's going to come from, but with a little bit of simplifying, cos times cos is equivalent to cos squared. We've got sine times sine over here. We've got a minus here and a minus there. So that is going to give us a plus. And we have cos squared plus sine squared. Now it doesn't really matter about the way around that it's written. Cos squared plus sine squared, sometimes referred to as sine squared plus cos squared, is equal to 1. And there's our derivative.